Hello, welcome to another episode of our further mathematics class. Okay, today we shall be looking at implicit differentiation. Implicit differentiation allows us to differentiate expressions that contains two or more variables. Implicit differentiation allows us to differentiate expressions that contains two or more variables. Alright, let's delve into it proper. Implicit differentiation. Okay, this is what we have today. Do not worry, there is no much difficult task here. Just follow my steps and you will get to solve this without any difficulties. Let's have an expression like this: x squared plus, let's say, y squared all equal to 20. For instance, we have an expression like this and we want to differentiate it. The principle behind this is that the terms in y, when differentiated, you should add the y over the x to it. It goes thus. Differentiating all, we have d of x squared plus y squared equal to 20 with respect to x. Alright? So when we differentiate all, we are going to have, if we differentiate this, we have 2x plus, if we differentiate this, we have 2y. Don't leave it like this. Multiply with what? dy over the x. Equal to, if we differentiate this constant 20, we have 0. Next is to subtract 2x from both sides. Subtract 2x from both sides. Alright, I want to get rid of 2x, that's why I'm subtracting it from both sides. So my 2x plus 2y dy dx all equal to 0 minus 2x minus 2x. These two goes away. We are left with 2y dy dx equal to negative 2x. Alright, having reached here, what we are going to do next is to divide both sides. Divide both sides by 2y. When we do it, we have 2y dy over the x equal to negative 2x. Here divided by 2y, here divided by 2y. So this goes, we are left with our dy over the x equal to, factorizing this, we have 2 multiply negative x all over 2 multiplying y. So these two cancels out. Our dy over the x will now be negative x over y. This becomes our answer. That is it for this. Okay, let us take another example using implicit differentiation to handle it. Okay, this we can tell number 1. Okay, let's take another example. Example number 2. We are going to find the derivative. Let's say x raised to the power 5 plus y raised to the power 5 all equal to 17. We have this to use implicit differentiation on. What are we going to do? Remember that if we differentiate a term in y, we add the y dx to it. So differentiating all, we have d of everything here, x raised to the power 5 plus y raised to the power 5 all equal to 17 with respect to the x. So when we differentiate this, we are going to have 5x raised to the power 4, because the general method says if you differentiate x, the power will multiply the base and subtract 1 from the power. Alright, that's what I need to get 5x raised to the power 4. Plus, if I differentiate y raised to the power 5, it will be 5y raised to the power 4. Okay, if I differentiate the constant 17 and we have 0. But you recall that we said when we differentiate a term in y, we should add what? The y, the x. That is the idea behind implicit differentiation. So here we are going to add what? The y, the x, because it is a term in y. We did it in first one when we differentiated y squared, we added what? The y, the x. So if we differentiate this term in y, we add what? The y, the x. Then when we differentiate the constants, it will still be 0. Having reached this far, what we are going to do is to make sure that this goes away. And how are we going to do that? We subtract 5x raised to the power 4 from both sides. Subtract 5x raised to the power 4 from both sides of this equation. Okay, so it will be 5x raised to the power 4 plus 5y raised to the power 4 dy over the x, all equal to 0. Subtract 5x raised to the power 4 from the left hand side and subtract from what? The right hand side. So it will be like this, 5x raised to the power 4. So when this becomes 0, we are left with our 5y raised to the power 4 dy over the x, all equal to 0 minus this will give us negative 5x raised to the power 4. Next is to divide both sides by 5y raised to the power 4. Divide both sides by 5y raised to the power 4. So this will now be 5y raised to the power 4 dy over the x equal to negative 5x raised to the power 4. Here being divided by 5y raised to the power 4. Here being divided by 5y raised to the power 4. So this will cancel out. Our dy with respect to the x will now be negative 5x raised to the power 4 all over 5y raised to the power 4. Okay, we erase this part of the board to continue our task. Alright, so watch carefully. Let's factorize that answer and get to the simplest form. So when we factorize this, we are going to have our dy with respect to the x equal to 5 multiply negative x raised to the power 4 all over 5 multiply what? Y raised to the power 4. So this can cancel out. Then finally our answer is now dy over the x equal to negative x raised to the power 4 over y raised to the power 4. This is our final answer. Okay, let's take another example, example number 3. Alright, in this example, I want it to contain product rule. Yes, I want it to contain a product rule. Okay, so let's go with x raised to the power 4 plus 2xy raised to the power 3 plus y raised to the power 4 all equal to 0. We have this example to differentiate using implicit differentiation. Watch carefully. As you can see, we are not just having terms in x and y, but we have a product of x and y at the center. There is what we are going to do here. Just listen attentively as I proceed with this work. Solution. If I have this, and to differentiate all, I will have d of everything x raised to the power 4 plus 2x y raised to the power 3 plus y raised to the power 4 all equal to 0 with respect to the x. Okay, having reached this far, if I differentiate this, I'm going to have 4x raised to the power 3. Okay? Now, the place that you should concentrate is this 2x y raised to the power 3. So we are going to cut it into 2 as a product, okay? We have 2x and y raised to the power 3. So what you are going to do for me here is, if you are differentiating something that have product like this, what you will do is differentiate the first term, bring down the second as constant. Then bring down the first as constant and differentiate the second. So we are going to have plus. If we differentiate 2x, we have 2. Bring down y raised to power 3 as a constant to multiply it. Okay? Then the next one, we put plus. We are going to bring this as a constant, 2x. Then we differentiate y raised to power 3. It will give us, this will now give us 3y raised to power 2. Because it is a term in y, don't forget to add the y over the x. Plus, if we differentiate this, we are going to get 4y raised to power 3. Don't forget your dy over the x attached to it. All now equal to 0. Okay, believe you have seen how to do this, especially when you have terms that have a product between them. Alright, we erase this part of the board, continue this task. If you don't understand anything, just pause this video, play it over again, you will understand what I just did there. Other than going to use the product rule to solve this and taking longer time, you have to differentiate one, bring the other as a constant, add your plus, bring the first one as the constant, and differentiate the second. Then, if it is a term in y, you add the y over the x to it. Like we have here, it's a term in y, we differentiate it and we add the y over the x to it. So, next is to collect like terms, if there is any. But if there is not any, we take the terms with the y over the x along. Okay, so what we are going to do is this one can be multiplied and this can also be multiplied. So let us multiply out those ones that can be multiplied. We have 4x raised to power 3 plus 2 times y cubed will give us 2y cubed. Okay, plus 2x times 3. 2 times 3 will give us 6 x y squared. Alright, remember it will be in the y over the x. You attach it there. Plus this will give us 4y cubed. Remember your dy over the x because it's a term in y. All equal to 0. Alright, having reached this far, we are going to move 4x cubed plus 2y cubed to the other side. So we are going to have this remaining 6xy squared dy over the x plus 4y cubed dy over the x all equal to 0 minus, this process becomes minus 4x cubed. This process becomes minus 2y cubed. Okay, factorize this. If they have dy over the x, it will be dy over the x. Open a square bracket. The first one we have here is 6xy squared plus 4y cubed. Bracket closes. This becomes negative 4x cubed minus 2y cubed. Alright. Having gotten to this length, divide both sides by 6xy squared plus 4y cubed. We are going to divide both sides by this. So our dy with respect to the x of 6xy squared plus 4y cubed equal to negative 4x cubed negative 2y cubed. Here being divided by 6xy squared plus 4y cubed. Same here. 6xy squared plus 4y cubed. These two will go away. Then our dy with respect to the x will now be, we can also factorize it. This is our answer. answer already. We can factorize it. We have a common term here. Okay, we can take our answer to be minus 4x cubed minus 2y cubed all over 6xy squared plus 4y cubed. If you like, you can factorize, but this becomes our answer. Thank you very much. And if you haven't subscribed to my YouTube channel, do so. Share this video, let it go viral. And if you have any questions, do that in the comment section. See you later. Bye.